Hi, I'd just like to talk to you about the changes since version 4 came out in July 2010. We've not been quiet, we've been quite busy, and in January 2012 we're going to launch a new version called version 4.2, and I just want to talk you through some of the things that we've changed. There's been lots of things under the hood that you won't notice. We've moved to a new development environment of Visual Studio 2010. We've actually changed and fixed a few bugs. We've got a new way of licensing the software. We're future-proofing it so it's ready for the next version of Windows. And you'll be pleased to know one thing that will affect you is that it is more able to be supported by smaller and cheaper graphics cards, such as the Intel embedded chipsets and some of the others. So the cost of hardware to run our software will actually be reducing. So that's really good news. Some things that you might notice if you're a long-time user: we've tweaked the way that the tube angulation control works because that had some erratic behavior. So you can now control that using the scroll wheel alone, and that just makes it much smoother to give those tube angles. The starting positions for several of the scenarios have changed. So, for example, in the trolley or gurney scenario, the starting position is now 72 inches or 180 centimetres away from the bucky, which means that you've got more space to wheel a trolley in there and it's much more realistic. We've improved the localization for our US customers. They were asking us to display collimation in inches, which we've done, and we've also tidied up some of the source image distances so that their exact inch equivalents are correct instead of the centimetre equivalents. And that will just work if you're in the US. And you can change it and configure it in other parts of the world to work that way if you want. You can actually change the table height, and the table height now has two detent settings. So if you raise the table height, it will lock at a certain height, and then if you take your finger off the lock button and raise it a bit more, then it will lock at a second height, which is very realistic to a real X-ray room, and it allows you to lock to 100 centimetres from the top of the table and then 100 centimetres from the bucky tray, and there's about 8 centimetres gap between those 2 points. So another thing we've been asked for and we've been able to implement. In the trolley trauma module, which I've got up here now, or the gurney module, we've actually been asked to give more flexibility for where you can actually put the cassette. So now you can drag the cassette away from the bucky on both sides of the bucky and actually put it on the trolley and image between the legs. You can place the cassette to image a knee or an ankle. So that really adds a little bit more flexibility there. Talking of configuration, we have a file which you can put settings in when you install the software, and the software will pick those changes up and it will work that particular way for your particular environment or your particular university. And we've added new settings in there that you can change. So for example, you can change the way the DICOM is saved and where it's saved. You can put the root of the directory that you want it to save in that config file, and that will allow you to get it uploaded to a PAC system. So these are all small little changes that have made quite a good difference. The console itself, we've upgraded that slightly in that it provides much more technical data under the technical data tab. It provides an estimate of incident dose, entrance surface dose, and it provides a value of median pixel value, which is a bit like an exposure index, which you can use to see whether you've given a correct exposure to the imaging plate or the detector. So these are nice additions which extends the curriculum that bit further, makes it even more useful in the classroom. On that same side, we've been really happy that we can actually now change in the scenario between CR and DR simulation. So if you're simulating DR, then you're using a flat panel detector rather than a cassette, and that means that the detector doesn't move when you've exposed it, it stays where it is. It makes it a lot easier in DR as it is in real life to take repeats. So we've implemented that, and it will also change the sizes of detector that are available. So that's a really nice new feature, which again extends the curriculum, allows us to talk about that in class. But I've saved the best till last. We've actually implemented the ability in a limited fashion to examine extremities. So knees and ankles can now be much more fluidly examined. And of course, we have a whole new workbook which has new lessons in it, which have updated from the last one, that are all pre-prepared with learning outcomes to really get you started on your journey to using the simulation software. So what I want to do now is just show you how these systems work. So I'm going to turn over to showing you the screen. Right, here we are in our trolley module. So we're halfway through examining a Darnelius-Miller or shoot-through lateral of the hip. I'm just going to turn the collimation on. I'm just going to drill in here and have a look. And I think we're a little bit high here, so I'm going to move down our collimation and open the collimation up a little bit, top to bottom. I'll also put a letter on, so that's good. And we'll move the cassette a little bit as well. Excellent. So if we go to the console now and expose this, and here we have our image. So I'll just use the image processing tab to spin it round and flip it, and here's our image of our right lateral hip. And if we go to our tech data, you can now see that in the tech data panel here we now have some new image data. We have the median pixel value of 62. We have the incident dose, which was 2.1 milligray for that exposure, and the entrance surface dose, which was 2.9 milligray, including the backscatter. So this goes along with the dose area product and the tube charge and the KVP. So you can really see how that would extend your ability to talk about the doses to the patient, which is a really hot topic at the moment in radiography. Now I just want to show you the flexibility of the cassette placement. So we'll zoom out here, and you can see that the room is much larger than it was before, and so we can move the trolley quite easily over to the other part of the room and spin it round, and if we get our patient, then we can move our cassette and quite easily position the cassette between the knees here. And that way we can now quite easily do a lateral shoot-through projection of the knee. I'd have to change that cassette to be a left letter, and that's quite easy to do. Okay, I'm going to change the scenario now and show how we can change from DR to CR. So if we change to CR, we now have a much larger selection of sizes of cassette. So we can pick an 1843, for example, and that's a size that is only available as a CR imaging plate. And if we go to the scenario and change to DR, then you can see that we only have a 3543 receptor or a 2430 receptor. And we also have the grid receptors, the 8-to-1 parallel grid receptors there. Now, if we So we'll just change the scenario now to lower limb. And I'll just show you the changes to the table height. So we're going to bring a patient in here and give them the name. Admit that patient. And while the table is at its lowest point, then our patient will just happily get on the table. And then we can actually click on the table base and drag it up to its first detent position. And if we stick on DR and select our 2430 receptor and put that on the tabletop, and you can see from the source image distance there that we're at 100 centimeters source image distance. If we put the detector in the bucky and then close the bucky, then we're now at 108 centimeters. So if we grab the table base and raise it that 8 centimeters more, then we're at 100 centimeters. So this is much more realistic, and the patient will not leave the table now because they are at a height, and until the table's brought down to all the way to the bottom, then the patient will leave the table when requested to. So that's much more realistic, we find. Now while we've got this patient here, I want to show you the exciting new functionality regarding the lower limb. So if we want to do a knee examination, then we'll do the left knee, so we'll put a left marker on the lateral side and we'll drag the receptor over to left hand side, looking for the apex of the patella where the joint space should be. And what we can do now is just drag the lower limb and internally rotate the leg until we're happy that the condyles of the knee are equidistant from the film and the patella's in the middle. So I think that's reasonable. I think probably need to come down a bit more. Okay, I'm happy with that. So now collimate and zoom out and just collimate to the area under investigation. Make sure our letter's still in the collimated area. And if we bring the console up here and go back to the examination, so we want lower extremity, knee left, recumbent, and an AP projection. And that will have filled the tube voltage and tube charge in. So we'll go into prep ready, and expose. And we have our lateral or AP knee. Now we're actually too internally rotated here, so I'm going to turn the knee out, and because we're in DR, the cassette is still there in the same location, so it's much easier to repeat. Some might say too easy, and we've now corrected our error. And you can see how useful that is. So it's been a while in us being able to bring you that functionality, but I know that I'm very pleased to be able to use this in the class with my students. Okay, well thanks very much for listening, and I'm just going to sign off now. But if you want a demonstration of this software and an ability to ask me questions and maybe show it to your colleagues, then we are able to do demonstrations over the web using a tool called WebEx, so we can actually interact with you wherever you are in the world. And we've done many of these demonstrations to South Africa, Canada, Australia, and we would be delighted to actually have an interactive chat. It's the sort of thing that can really be scheduled during your staff meeting, so that it can be a bit of an exciting, sort of interesting afternoon or morning meeting. And we would be delighted to facilitate that for you. And of course we have 2 other programs that you might be interested in. We have Lecture VR and Technic VR, both of which are going to have some additional improvements in 2012. So watch this space. Thanks very much for listening.